All right, welcome back to our notes video sessions for Unit 7. Today we're on Notes 3, which is talking about combinations. It's Miss Johnson here, and I'm going to be taking you through our notes today. Your example up at the top talks about arranging teams to play each other. We have 5 teams playing in a basketball tournament. How many different matchups are possible? Let's make a list. Now, for name's sake, I'm just going to call the teams A, B, C, D, and E. And let's make a list of all of the possibilities that we could have. I could have A and B. I could have A and C, A and D, A and E. I could have B and A, B and C, B and D, B and E. I could have C and A, C and B, C and D, C and E, D A, D B, D C, D and E. And I could have E with A, E with B, E with C, and E with D. Now, let's take a look at those. Each one of those is a different basketball game. So here's my question to you. Is playing the two teams A and B different than the teams B and A playing each other? Does it make a difference? No, it's the same game. So this one actually doesn't count. We don't need it, okay? Also, I have C and A and C. Again, they're the same thing. We don't need them. I've already got BC with CB in the same, so I'm going to get rid of it. DA is the same as AD. I'm going to get rid of it. DB is the same as BD. Get rid of it. DC is the same as CD. Get rid of it. Over here, I've already got A with E, so EA is gone. I've already got B with E. EB is gone. I've already got C with E. EC is gone. And I've already got D with E, so ED is gone. So I got to eliminate a lot of those different possibilities because it's the same game. I'm not going to list it out twice. So let's look at how many we have left. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different matchups for that basketball tournament. Now, this is a little bit different than what we talked about yesterday. What makes this a combination is that it's still arranging or pairing or grouping objects, but now the order is not important. Okay, Team A playing Team B is the same as Team B playing Team A. So it's a combination is an arrangement or listing of objects in which order is not important. Yesterday we talked about permutations, order was important. So now combinations, order is not important. Let's take a look at how that changes our formula. There's one very subtle difference from the permutation formula yesterday. We still have n factorial over n minus r factorial, but now I have an extra r factorial in the denominator. Okay, so I'm going to take a look at how that changes my calculations. In number 2, I'm calculating the combination of 6 objects taken 2 at a time, or 6C2. That is the same thing as 6 factorial over 6 minus 2 factorial times that extra 2 factorial. Okay, 6 minus 2 is 4, so that's going to be 6 factorial over 4 factorial times 2 factorial. And if I write all that out, I have 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. Now, remember that any number over itself is 1, or any number divided by itself is 1, so I can get rid of some stuff here. 4 over 4, gone. 3 over 3, gone. 2 over 2, 1 over 1. I can also reduce. I've got 6 up here in the numerator, and I've got 2 down there in the denominator. If I take 6 divided by 2, I get 3. So I can cancel that out and make that 3. And then we all know that dividing by 1 doesn't do anything, so look at what I have left. I'm left with 3 times 5, or 15. Okay, I want you to pause the video right now and see if you can calculate 8 C3, or the combination of 8 objects taken 3 at a time, in number 3. Let's move on to number 4. In number 4, it says a group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be peer tutors. Mr. Picard is going to pick 12 of them to be peer tutors. So we need to figure out how many different combinations of students we could have. Now, the order doesn't matter here because they're all just going to go into the same room and be peer tutors together. It doesn't matter what order they go into that room in. So I need to look at how many kids I have. I have 7 plus 5 plus 4 students. That means I have 16 total. And I'm choosing 12 of them. So I have 16 choosing 12. Okay, that's the same thing as 16 factorial over 16 minus 12 factorial times that extra 12 factorial in the bottom, which is 16 factorial over 4 factorial times 12 factorial. Let's write all that out and see what it looks like. 16, 15, 14, and so on. Uh-oh, we're going to have to write over Mr. Picard here. Oops, 2 and 1. In the denominator, that's a long fraction. I have 4 factorial, 4 times 3 times 2 times 1. I also have 12 on down. All right, so let's take a look at how that's going to change our answer. We know that 12 on down is going to cancel because 12 on down is in both the numerator and the denominator. So we got to get rid of all of those. Also, look at what's left in the denominator. I can cancel out some of that stuff. 16 and 4, I can divide. 16 divided by 4 is 4. So I'm going to get rid of that. 15 and 3 I can divide. I'm going to get rid of the 3, and I'm going to make that 5, because 15 divided by 3 is 5. I can also divide 14 and 2. 14 divided by 2 is 7. So I could make that 7. And again, dividing by 1 doesn't change anything, so I don't need it. So hopefully you're writing neat enough in these, because you can see there's a lot of different marks going up on that screen. So let's take a look at what's left. I've got the 4, the 5, the 7, and don't forget about the 13 that's still there. So if I multiply those out, 4 times 5 times 7 times 13, I'm looking at 1,820 ways. 1,820 different groups of tutors that Mr. Picard could pick. Let's take a look at number 5. In number 5, it says you and 6 friends are going to lunch. You can only take 2 people in your car. How many different ways can you, or how many different combinations of friends can you pick? So I have 6 friends to choose from, and I'm choosing 2 of them to go with me in the car. That's the same thing as 6 factorial over 6 minus 2 factorial times that extra 2 factorial down there. 6 factorial over 4 factorial times 2 factorial. Let's write it on out. 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And that extra 2 factorial is down there as well. So we know that 4 cancels 4, 3 over 3, 2 over 2, 1 over 1. And again, I can reduce some other stuff too. I can take 6 divided by 2 and make that a 3. Dividing by 1 doesn't matter. So taking a look at what's left, I have 3 times 5, which is 15 different ways, or 15 combinations. I want you to pause the video at this time and see if you can figure out number 6. Now, half the battle between permutations and combinations is just figuring out which one it is, because they're not going to say the permutation of such and such. You have to determine, does the order matter or not? If the order matters, it's a permutation. If the order does not matter, it's a combination. So let's look at number 7. In number 7, we have 8 empty seats on a subway and 5 people to sit in them. Now the question is sitting in one seat different than sitting in another? Well, yes it is, because the first person who gets on, if they take the first seat, now the next person's in a different row. So this order makes a difference. This is going to be a permutation. Okay, now let's calculate it. I have 8 seats, and I'm choosing 5 of them for the 5 people. That's 8 factorial over 8 minus 5 factorial, or in other words, 8 factorial over 3 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1, and cross it out. That's the best part about all these questions. So what's left is 8 times 7 times 6 times 5 times 4, and if I multiply all those together, I get 6,720 different ways that those 5 people can sit down. In number 8, you're looking at the history test with 5 presidents that you need to compare 2 of them in an essay. Now, does it matter if you compare Bush to Clinton or Clinton to Bush? Does that make a difference? No, it doesn't. The order doesn't matter. You're still going to pick 2 and compare them. So in this case, we're looking at a combination because the order that we choose those presidents doesn't make a difference. We've got 5 to choose from, and we're choosing 2 of them. So this is going to be 5 factorial over 5 minus 2 factorial. Don't forget that extra 2 factorial in the bottom because now we're looking at combinations. That's the same thing as 5 factorial over 3 factorial times 2 factorial. And if I write all that out, that's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times that extra 2 and 1. There. Crossing out what I can, 3 and 3, 2 and 2, 1 and 1. That 1 doesn't matter. I'm going to divide 4 and 2. 4 divided by 2 is 2. So I'm left with 5 times 2, or 10 different essays that you could write. 10 different ways you could compare those presidents. I want you to pause the video for a second and see if you can calculate number 9. Let's move on to number 10. In number 10, we're looking at 20 students in a speech club, and we're picking 3 of them to represent the school. So I have, well, first of all, permutation or combination. Does it matter what order I pick those 3 people? No, because they're just going to go and represent the school. They're all going to go together. So this is a combination because the order does not matter. I have 20 people to choose from, and I'm choosing 3 of them. Now, 20 is a lot bigger number to write out. So what I want to consider at this time is let's figure out what's going to be left, okay? So I have 20 factorial over 20 minus 3 factorial times 3 factorial. That's 20 factorial over 17 factorial times 3 factorial. Now we're always trying to find ways to make it a little bit easier on ourselves, so consider this. Everything from 17 on down in the top and the bottom is going to cancel out. So I'm just going to write what will be left. That means I have 20 times 19 times 18 on the top, because everything from 17 down is going to cancel. But I also have this. So I have divided by 3 times 2 times 1. Well, we all know dividing by 1 doesn't matter. If I look at 3 and 2, 3 times 2 is 6. I can take 18 and divide out 6. So get rid of both of those. 18 divided by 6 is going to be 3. This has just become a much simpler problem. So I have 20 times 19 times 3, and that gives me 1,140 groups. Okay. And the last one we are going to talk about in class tomorrow. So thanks for watching and have a great night.